explain braking capacity test performed on circuit. The braking capacity test verifies the ability of a circuit breaker to interrupt or say break the rated short circuit current safely at the instant of fault failure. When a fault occurs, the breaker must open and interrupt very high fault current. This test ensures safe interruption without restrike, reignition, or insulation failure. The test is carried out to confirm that the breaker can interrupt the rated symmetrical short circuit current, to check the arc quenching capability of the interrupter, to ensure insulation can withstand the transient recovery voltage, that is TR, after the interruption, and to verify that no damage, welding, or deformation occurs. In this test, a controlled short circuit is created through the breaker. Breaker is commanded to open at a specific point on the current loop. First, the master circuit breaker and then the circuit breaker under test is made on. Short circuit is made by making the make switch on. The circuit breaker under test is open at the required distance. The following quantities are found from oscillogram. Those are recovery voltage during the test, symmetrical braking current, asymmetrical braking current, amplitude factor, natural frequency, and rate of rise of restriking voltage. The breaker passes the braking capacity test if fault current must be fully interrupted, no restrike or reignition, contacts and mechanism must remain undamaged, and rate of rise of restriking voltage should remain within the permissible envelope. The test proves that the breaker can clear real short circuits on the power system. So this is about braking capacity test performed on a circuit. Explain duty cycle test performed on circuit breaker. So this test checks whether the circuit breaker can perform a sequence of open and close operation under high stress fault conditions as required in service or not. The standard sequence is O-T-CO-T-CO, where O means open under fault, T is the time interval, that is short duration, CO means closing operation followed by the opening operation under the fault again, and then again the T is the time interval which is longer than the previous one, and CO, that is the closing operation followed by the opening operation. This simulates how a breaker behaves during the auto reclosing and successive faults. The following duty cycle tests are performed. First is B-3-B-3-B. Test is done at the 10%, 30%, and 60% of the rated symmetrical braking capacity of that breaker. Here B means the braking operation. So first braking, then the delay of 3 minutes, then the again braking, then 3 minutes delay, and again braking. So this test is performed for 10%, 30%, and 60% of the rated symmetrical braking capacity of the breaker under test. Now second test is performed as B-3-MB-3-MB. Test is performed for, first is at not less than 100% of the rated symmetrical braking capacity, and secondly at not less than 100% of the making capacity of the breaker. This test can also be performed as two separate tests. First is M-3-F, that is making test, and second is M-3-B-3 braking test. Also B-3-B-3, that is the braking 3 minutes, braking 3 minutes, braking test are performed at not less than 100% of the rated symmetrical braking capacity test. Here the B means the braking operation, M means the making operation, and MB both together suggests that it is the braking operation just after the making operation without any time delay. 3 denotes the time delay in 3 minutes. So this test is carried out to verify the mechanical and electrical endurance under the repeated rated stresses to check app quenching ability of the multiple interruptions and to confirm that the breaker can perform successive fault clearing operations quickly. Now, the breaker passes the test if breaker must complete the entire duty cycle, no restrike, no reignition or dielectric failure. Mechanism must not jam during the operation, must not bend the contacts or excessively wear, and contact erosion must not be done, or if done or occurred, it should be within the specified limit. This is one of the most important type tests, proving the breaker can handle successive faults, auto reclosing operations, and real-time system duty cycles under the fault conditions. So this is all about the duty cycle test performed on circuit breaker. Explain short time current test performed on circuit breaker. So this test checks whether the circuit breaker can carry the rated short circuit current for a specified duration, that is typically for 1 second or 3 seconds without damage. It does not interrupt the current, it only carries it. This test is carried out to verify the thermal strength of the current carrying parts and ensures the breaker survives the thermal and magnetic stresses during the faults. In this test, the breaker is kept closed, rated short time current is passed through it for 1 or 3 seconds, and temperature rise, deformation and vibration are monitored. The breaker passes the test if no deformation, loosening or burning of contacts and conductors, temperature rise within the permitted limit or specified limits, and no damage to insulation or mechanical parts occur. It ensures the breaker will remain intact until the protection clears fault on the system. So this is all about the short time current test performed on circuit breaker. State the various routine tests performed on circuit breaker. Some of these are power frequency voltage test, millivolt drop test, operational test, voltage test on the auxiliary and control. Explain. Millivolt drop test performed on circuit breaker. So, the millivolt drop test, also known as the contact resistance test, is performed on a circuit breaker to measure the electrical resistance across the main contacts when the breaker is in the closed, that is on position. This test ensures that the breaker contacts are healthy and capable of carrying the rated current without excessive heating or energy loss. The test is carried out to measure contact resistance across the breaker contacts, detect deterioration such as heating or erosion from RP, oxidation or moisture contamination, loose or misaligned contacts or high contact film or wear, etc. Low resistance ensures better conductivity and reduced energy losses, whereas higher resistance indicates poor contact, which can lead to localized heating, increased losses, or even failure. Firstly, ensure the breaker is in closed position. Connect the current leads to both the ends of the contacts and voltage leads across the breaker terminals, that is Kelvin 4-wire method. Inject a known value of a DC current, that is steady current, through the breaker into the system, usually 50 ampere, 100 ampere or more depending on the rating. Measure the voltage drop in millivolts across the contacts with micro-ohmmeter or ductor tester. So the millivolt drop test is a critical diagnostic test used to ensure the mechanical and electrical health of the circuit breaker contacts. It provides an early indication of wear, corrosion or misalignment, helping prevent overheating, efficiency loss and catastrophic failures during the operation. So this is all about millivolt drop test or contact resistance test performed on circuit breaker. Explain operational test performed on circuit breaker. So an operational test is one of the key routine tests carried out on a circuit breaker to ensure that it performs its intended switching and protective functions correctly under normal working conditions. Unlike the type test, which verify the design only, and special test, operational test confirms proper functioning of the installed mechanism and control circuitry. Operational test verifies that mechanical opening and closing mechanism works correctly. Control circuits, that is trip coil, closing coil, auxiliary contacts operate as intended or needful. Breaker performs manual and automatic operations smoothly and reliably. Proper functioning of interlocks, safety switches and alarm circuits. In this test, we verify that breaker is correctly installed and confirm that control wiring and auxiliary contacts are connected properly. Operate the closing mechanism manually and confirm the breaker moves to on position smoothly. Use the mechanical trip button and confirm instant and complete breaker opening. Apply electrical closing signal and verify its closing action. Now apply a trip signal from control relay or test switch. Attempt prohibited operations to confirm the interlocks work properly or interlock stops them. Perform repeated on and off switching cycles to verify the reliability. The breaker passes the test if it must close and open without any delay or abnormal sound. Trip command must open breaker within rated operational time. All auxiliary contacts must correspond correctly with the main contacts and no mechanical jamming, bouncing or sluggish movement is acceptable. It ensures reliable real-world operation of the breaker, confirms compatibility with protection relays and SCADA systems, and helps detect mechanical wear, wiring errors or linkage problems before energizing the system. So this is how the operational test performed on a circuit breaker is very important type of routine test to verify the operational sequence as well as the functioning of the circuit breaker. Explain auxiliary and control circuit voltage test performed on circuit breaker. So the auxiliary and control circuits of a circuit breaker include components like closing or tripping coils, spring charging motor, indication lamps, relays, heater circuits and interlocking circuits. These circuits operate at a low voltage or the low control voltages ranges from 24 volt, 30 volt, 48 volt, 110 volt, 220 volt, either DC or AC depending upon their designs. The auxiliary and control circuit voltage test is conducted to ensure that all these components operate correctly and reliably at specified minimum voltage, maximum voltage or the rated voltages. The purpose of this test is to verify correct functioning of all auxiliary devices at rated control voltage, minimum operating voltage and maximum operating voltage. Also, to ensure that the breaker closes and trips properly, spring charging motor operates correctly, all indication and alarm circuits work and interlock responds correctly. Moreover, it is conducted to confirm reliable performance during abnormal voltage conditions like low battery voltages, high voltage fluctuations. In this test, the rated voltage is applied, that is 110 volt or 220 volt DC to control the auxiliary and control circuits to check the closing operation of circuit breaker, tripping operation, indication lamps, that is all the lamps like on, off and spring charge, all the three indication lamps, coil consumption, that is the current measurement during the operation, and spring charging motor operation. Also now apply the minimum control voltage, typically 70 to 85% of the rated voltage depending on the standards. The breaker must successfully trip and close. Motor charging may start but may run slowly because of the low voltage available at the motor terminal, and this is acceptable generally because of the low voltage operation. Now apply the maximum control voltage, usually 10 to 20% more than the rated value, that is 110 or 120% of the rated voltage, and verify that no overheating occurs, coils do not chatter, indications do not fail, and motor does not draw the abnormal heavy current. Record and measure closing coil current, tripping coil current, motor charging current, operating time at minimum, rated or maximum voltages, and verification of the interlocking operations. The breaker is said to pass the test if, according to IEC or Indian standards, breaker must close and trip at minimum voltage, auxiliary circuits must withstand maximum voltage without any damage, no abnormal noise, overheating or sluggish operation. All auxiliary relays, switches and lamps must function properly or correctly, and sequence of the operations, that is closing, opening, tripping and motor charging, must be smooth enough. So this is all about the auxiliary and control circuit voltage test performed on a circuit breaker. Explain basic details of HVDC circuit breaker and state the difficulties with it. So in AC circuit breaker, the value of the current becomes zero twice in a cycle, that is rising again zero and falling in the negative half cycle and again reach to zero. So in AC circuit breaker, the circuit is open when the current passes through natural zero, and the main question is to prevent the restriking of the arc. Now, while the DC circuit breaker, the current does not pass through natural zero, so it becomes necessary to bring the short circuit current to zero value by some another means. Another problem is to dissipate the high value of the stored electromagnetic energy during that period. So in HVDC circuit breaker, the following problems are to be solved, or the main difficulties associated with HVDC circuit breakers are to create the condition of the current zero, to prevent the restriking, and to dissipate the stored energy. So this is the basic details of HVDC circuit breaker and difficulties associated with the HVDC circuit breaker. Explain current zero condition creation in HVDC circuit breaker. So in case of HVDC circuit breaker, you can visualize the bipolar transmission line here connected as one is positive and one is negative. The polarity is marked in the figure. You can visualize here this. It is positive and here it is negative. This is the main circuit breaker M. It is closed in the positive pole, and as the DC circuit breaker, in case of it, the positive and negative poles or polarity is marked. So current is never flowing through natural zero, and actually no current zero instant is created or naturally in HVDC circuit breaker. So in that case, oscillatory circuit is used to create the condition of the current zero. A series resonance circuit comprising of inductor and capacitor is connected as shown in the figure. So here it is shown that the M is the circuit breaker, S1 is the normally open switch, and S2 is the normally open contact, and L and C forms the series circuit or series resonance circuit. So in this, current is flowing from M to L, charges the capacitor C to the line value of this, and from NC to resistor and negative polarity. So this is how the cycle is completed. During the normal operating condition, S1 is open and S2 and M both are in closed condition. So the capacitor charges to the line value of the voltage through the path M, L, C to R like this. This voltage is across the contact S1. So it is the contact S1 which is open, and this voltage of the capacitor is directly came across the normally open contact. Now to interrupt this DC current, contact S2 is opened up and S1 must be closed when the fault occurs. Now during the fault condition, this S1 and S2 both changes its status. So S1 is changing its status from normally open to closed and S2 from normally closed to open circuit. Now due to this, the capacitor discharges via path L, M, S1 to C. So this is how the capacitor is discharging and opposing the main current. Due to this, the oscillatory current is produced as shown in the figure. You can visualize in this figure. This is the oscillatory current. Circuit breaker M is opened up when the current passes through this zero instant. So when the current passes through the zero, the breaker opens up, then the contact S1 is opened and breaker is closed. So this is how the current zero condition is created in HVDC circuit breaker. Explain current zero condition creation using non-linear resistance. So in another method of interrupting the main circuit direct current, the main current is diverted through the capacitor. So in this case, you can visualize this. This is the main breaker that is in closed position. This is the capacitor and a non-linear resistor is connected in parallel with this contact. Due to this, the current to be interrupted by the circuit decreases as shown in the figure. Previously, we have seen this the oscillatory circuit or the current. Capacitor C is initially in the discharge condition. Now when the main contact M is open during the fault condition, the main current is diverted through this capacitor C. So the current is diverted through this capacitor. The value of the rate of rise of recovery voltage, that is RRV, is non-linear resistor absorb the energy and the voltage across the main contact decreases and current is gradually decreased to zero and the breaker is in open condition. So this is the current zero condition creation using the non-linear resistance. Explain restraining of restriking in HVDC circuit breaker. So it is the second difficulty associated with HVDC circuit breaker that the restriking of the arc should be restrained or say avoided. This difficulty in oscillatory DC circuit is because of the period for the current chopping is 100 microseconds, which is very less. So steep surge of the restriking voltage is produced across the breaker terminals. When the breaker is open, this surge voltages came directly across the terminals of the breaker. So the circuit breaker should be capable of or able to withstand this surge voltages during this period. For deionizing the arc space is made narrow and the arc is split up into very small parts with the help of gratis, that is the metal vertical plates, or you can say it is a separator. So with the help of it, the arc is deionized and the restriking of the arc is restrained in HVDC circuit breaker. Explain dissipation of stored energy in HVDC circuit breaker. So the stored energy in the inductor should be dissipated during the current interruption. Otherwise, this energy is transferred to the capacitor and overvoltage is produced due to the excessive energy. A spark gap is connected across the circuit breaker. This reduces the size of commutating capacitor. This reduces the value of the abnormal voltage. Now the value of the transient recovery voltage is decreased as the opposition of the current flowing from the capacitor charged during the period of normally open contact and the breaker is in closed position, and the energy is dissipated via connecting the ZNO arrestor across the breaker. So this is how the dissipation of the stored energy or the problem is solved for the third main issue associated with the HVDC circuit breaker.